Let's take a look at how we can use the division method to obtain the LCM and HCF of numbers. This method involves using prime numbers to divide numbers given to obtain their HCF or LCM, and both involves division, usually done in table form. So let's begin by trying to find the LCM of 24 and 30. First, we'll draw our table to be something like this. Then we place 24 and 30 side by side as shown here. The process for this involves a repetition of steps, as we only have to find prime numbers that divide into any of the numbers or both of the numbers until we get 1 as our final value under both columns. So first, 2 divides into 24 to give us 12 and divides into 30 to give 15. Then we also look for another prime number that divides into 12 or 15 or 12 and 15. 2 divides into 12 but does not divide into 15. So it divides into 12 to give 6, and since it does not divide into 15, we just write down 15 again. Now we find another prime number that can serve the purpose. 2 will divide into 6 but not into 15. So it divides into 6 to give 3, and we just write down 15 again. Now at this point, 2 will not divide into any of them, but 3 will in fact divide into both 3 and 15. So 3 divides into 3 to give us 1, and divides into 15 to give us 5. Here we do not need to worry about the 1 that we have under 3. So the next prime number we need to consider here is 5, as it will divide into 5 to give us 1. And we can just bring down this 1 here. Now that we have only 1 as our final values, we can take the LCM to be the product of these numbers, which will be 120. Let's move on to finding the HCF of 24 and 32. We begin by drawing our table again and placing 24 and 30 side by side as shown here. What makes this process different is that the prime number must divide into all the numbers under consideration until the final values are co-prime. That means the final values will not have any common factors. So we begin with 2, since it divides into both 24 and 30 to give 12 and 15 respectively. Now we have to find another prime number that divides into 12 and 15, and that would be 3. 3 divides into 12 to give 4 and into 15 to give 5. Now we have arrived at co-prime values, what this means is that no number can divide into both 4 and 5, hence they have no common factors. With this, we can safely conclude that the product of 2 and 3 here will give the HCF, which is 6. It is also important to note that when we multiply these numbers here and here, going in the L direction, we obtain the original value for the LCM. You go in the L direction to get LCM. Anyways, an important tip is that the LCM is always greater than or equal to the greatest of the numbers you are working with. That is why the LCM here is bigger than 30. And the opposite applies for HCF, where it is usually smaller than or equal to the list of the numbers you are working with, which explains why 6 here is less than 24. So we can easily summarize their differences in terms of how we divide with prime numbers, what we have as our final values, and also whether the value obtained is greater than or equal to or less than or equal to either the highest or smallest number given. Finally, when we take the HCF and LCM of 24 and 30 and multiply them, we get 720. 720 is also the value we get when we multiply 24 and 30. So we can safely conclude that the product of two numbers is equal to the product of their HCF and LCM. Thank you so much if you watched up to this point. I really hope you are getting value out of this. Share this, subscribe, and like if you can. Goodbye.